Myself Amreen Rawat. Today we are going to start with a new topic of Standard 9th State Board. So in this topic we will try to understand why bodies float on water or on the liquid. To understand this, first let us do a small experiment as usual how we did in the last time. In this experiment you have to take a pin, a block of wood and a paper pin and a paper. Try to press the block into the paper and observe and write the observation. The second thing, on the same piece of paper, try to press the pin with the same amount of force with the help of your thumb, and again write down the observation. We will discuss the observation and conclusion of this experiment in the end of the chapter. Now let us see what is the meaning of thrust. What do you mean by thrust? The force acting on a body perpendicular to the surface is called thrust. Now what does it exactly mean? It also, because of thrust, we can define pressure also. What is the definition of pressure? We define pressure as the amount of thrust required on a particular area. Or we can also say that thrust on a unit area is called pressure. By mathematically we can say pressure is equal to thrust upon area. The SI unit of pressure is Newton per meter square, where thrust, which is the force, is Newton and meter is the area. It is also denoted as Pascal, as the term pressure was given by Pascal, the famous scientist and the mathematician Pascal. Pascal also gave the unit of measurement of pressure as well as the instrument to measure pressure, and the instrument to measure pressure is called barometer. So can you please tell me what do you mean by fluid? Actually, all liquids and gases are called as fluid. Fluid means the substance with the tendency to flow. Now fluids also have a special property that they exert pressure on the base as well as the walls of the container which holds it. It also exerts pressure on the substance which is immersed into the liquid. This is a special property of a fluid. Because of this pressure exerted on the confined mass of this fluid is transmitted undiminished in all the directions. Liquids are differentiated from the gases by their property of possessing a definite volume and a definite temperature. They differ by each other with the property that they have the tendency to change with the temperature. Now what happens with how the pressure works in case of gas? In case of gases also exert pressure in all the directions. It also exerts pressure on the container. The pressure in the gases is due to the motion of the molecules. Air exerts pressure in all the directions. The pressure of the air is due to the collision of the molecules. Now this air molecules or gas molecules, they are always in random motion, and due to this random motion they collide with each other as well as they collide with the wall of the containers, and due to the collision they create a pressure into the system. The atmospheric pressure also depends on the place or the height of the place. As we go higher and higher from the sea level, the atmospheric pressure decreases. The atmospheric pressure decreases. At the sea level on the surface of the earth, the atmospheric pressure is 10⁵ pascals, which we do not feel, but it is there. We do not feel it so large because of the pressure of the blood. The pressure of the air is negligible to us. Some people, when they climb at higher altitudes, they feel restless or breathless. Some people also feel ear popping when they climb the mountain. Why this thing happened? This is just because of the atmosphere. atmospheric pressure, which goes on decreasing as the height of the surface of the earth increases, as we go higher and higher from the sea level. Now let us just jump on liquid pressure. Now what is liquid pressure? The pressure exerted by the liquid on any object is called liquid pressure. Now this term we can understand well with the help of swimmers. If we have seen many swimmers swimming, the weight of the swimmer is balanced by the water level. How it happens? This is just because of the liquid pressure. So let us perform another experiment to verify the pressure of liquid. In this experiment, you have to take 3 bottles of different sizes. In this 3 bottles, in the very first bottle, make 3 holes which are at the same heights. In the other bottle, make 3 holes at different heights. And in the third bottle, make 3 holes which are quite apart from each other at different heights. Now fill this bottles with water. After a while, just release the taps of the bottle and observe the following. Whatever thing happens after releasing the tap, you will observe that water from all the 3 bottles of 3 different sizes will come out with the same pressure. Performing this experiment, we can conclude that the pressure of liquid on the walls of the container is equal throughout the container. We can also say that the pressure of the liquid does not depend on the size and shape of the bottles. In this way, we can understand the pressure of water well. In the very beginning of the chapter, we performed an experiment in which we were trying to push a pin as well as a block of wood into the paper. It was very difficult for that wooden block to get inside the paper, but the pin easily went inside the paper. Why is it so? Because the pressure exerted on smaller area is much larger than the pressure exerted on the larger areas. Because of this property of pressure, we can easily push the pin inside, and it was difficult to push the wooden block. Similarly, it is recommended to wear flat slippers on the icy land or in case of sand, when we are walking on the sand. The same principle applies. If we are wearing heels and walking on the sand, it will start piercing in the sand, and because of this motion, it will be very difficult to walk. While wearing flat surfaces, because of larger surface area, it will help to walk properly, as the pressure exerted on the surface of the ground will be less. The same principle applies while cutting vegetables. While cutting a vegetable, we use sharp knife because we can apply maximum pressure on the sharp edge of the knife because of the less surface area, while we cannot use wooden block or anything which is blunt to cut the vegetable, as the pressure applied on the large surface area will be much less than compared to the sharp edge of the knife. Now let's proceed to the next part of the chapter. The next topic is buoyant force. Now what is buoyant force? To understand buoyant force, we will again perform an experiment. Now in this experiment, take a bucket full of water. Try to insert an inverted bottle into that water by pressing it. Note down the observation. What you will observe is it will just push up the bottle in the upward direction. Why this happens? This happens because the liquid surface is having some energy, some force, which is called as buoyant force. So we can define the buoyant force as, the upward force exerted by the water on the bottle. It is also called as upthrust. It is a kind of force which is when partially and fully dipped into a liquid, the liquid exerts force on that body. The force exerted by the liquid is perpendicular to the surface of the body, and it is equal to the product of pressure and area at the same point. Have you ever drawn water from the well? You must have noticed that the bucket which appears lighter underwater. Have you ever drawn water from the well? If you have done that, you will notice that when the bucket of water is submerged into the well, water of the well, you will feel no weight of the bucket. And as soon as you pull it up, you'll feel the weight. Why it happens? This happens because the bucket, any object which is submerged into the liquid, it loses its weight inside the liquid. And because of this property of the liquid, because of which the submerged object loses its weight, and the water again throws that object in the upward direction, is called buoyancy. It depends on two factors: the volume of the object and the density of the liquid. This buoyant force depends on two factors. First is the volume of the object. If the volume of the object is greater, the buoyant force exerted by the liquid will be greater. Second is the density of the liquid. If the buoyant force is maximum when the density of the liquid is greater. Now let us proceed with the other part of the chapter. You must have noticed that some objects float in the water while some sinks inside. So there are some factors causing these things. Now let us study what factors are responsible for floating and sinking of the object. The very first thing, the buoyant force. When the buoyant force exceeds the weight of the object, it floats. Second thing, if the buoyant force is less than the weight of the object will sink. And if the buoyant force is equal to the weight of the object floats inside the liquid. Let us do another experiment to find some new things. For this experiment, this can be performed in the practical lab. For this experiment, take a piece of stone, tie it with a rubber string, and just release the rubber string. You will observe that the rubber string goes on extending till a little bit. After some time, just immerse that rubber string into water. You will observe that the elongation of the rubber string stops or it becomes slow. Why does this happen? This happens because the elongation of the string is because of the weight of the stone. But as soon as it is dipped into the water, the weight of the stone is lost into the liquid, and because of which the elongation of the rubber string stops. The elongation of the string is produced due to the weight of the stone. As soon as it is dipped in the water, it loses its weight in the liquid, and because of which the string goes to its original position. It was well stated by Archimedes, which is known as Archimedes principle. The principle states that when a body is immersed partially or completely into a liquid, it experiences an upward force, and that force is equal to the weight of the object. Using this experiment, we can also find the volume of the substance, either liquid or a solid. Now the applications of Archimedes principle. Where is it applied? Archimedes principle is highly applicable in the construction of submarines and ships. In the construction, while constructing a submarine, it is constructed with huge tanks. These tanks are either situated at the front or back of the submarine. If it is filled with water completely, the weight of the ship increases and it sinks into the water. And by removing the water, by pressing compressed air into the tank, the weight of the tank decreases, and due to this, the submarine can again come to its floating part, and it floats and becomes a ship. In this way, Archimedes principle is used. There are some instruments also to measure the pressure using this principle: barometer and hydrometer. Hydrometer was used to find the purity of the sample of milk, while barometer is used to find the pressure into a liquid. In this way, Archimedes can be used in various purposes. Now the next part of the chapter, let us discuss what is density. Density actually means something which is little complicated, so let us explain it in a different way. This is a tree, a place where there are many trees is called forest. And if all the trees are closely packed together, such a forest is called a dense forest. Similarly, in case of a substance, an object or a liquid, we see molecules. The packing arrangement of the molecules is called density of the liquid. In that case, if the molecules are very closely packed to each other, then it is a liquid. When there is no space between the molecules, then it is a solid, and when there is a little bit of space and when it is not packedly closed, such a substance, such a thing is called gas. So this is the way how we can explain density. This is the density of a liquid. We can define it as the way how closely the molecules or the matter is packed in an object. So we can define density as the number or the amount of matter present in a volume. The density of liquid can be defined as the amount of matter present in a particular volume of liquid. So density is equal to mass upon volume, that is the amount of matter present in a particular volume. So mathematically we define density as mass upon volume from this formula we can derive the unit of measurement. So how to derive? The unit of measurement for mass in the SI unit is kg, whereas for volume in the SI system is meter cube. So we can say the unit of measurement for density in the SI unit is kg per meter cube, whereas in the CGS system it is gram per centimeter cube. Now what do you mean by the term relative density? Relative density means you have to compare the density of the given object with the density of water. So mathematically we can write relative density as the density of the given substance divided by the density of water. As the density of substance, that is kg per meter cube, and density of water, that is again kg per meter cube, gets cancelled, relative density, or in short RD, has no units. It has no units. So what we studied about relative density is the comparison of the density of the substance with the density of water. For that purpose we need to divide the density of a substance with the density of water. If we have to find the unit of measurement of relative density has no unit of measurements. will see some examples related to the theory that we have studied. The very first example, we have to calculate the pressure exerted by the screw on the wooden plank. If the area of contact of the screw is 0.5 millimeter square and the weight is 50 Newton. So first we will write down the given points. Given is area, that is 0.5 mm square. So we can convert it into SI unit as 5 into 10 raised to 6 meters. Then then the next part is the weight. Weight is 50 Newton. Weight is actually the force that is exerted on a body due to gravitation. So we write it in terms of Newton because it is a force. So weight is 50 Newtons. The formula for pressure is equal to force upon area. Now substituting the values we get. So let us just first start noting down the given data. The very first given data is area, which is 0.5 mm square. On converting this, we get 0.5 into 10 raised to minus 6 meter square. Then the next data given is weight. Weight is actually the force exerted on a body due to gravity. So we write it in terms of force, that is 50 Newton. The formula to find pressure is force upon area. Now substituting the values, force is 50 Newton divided by 0.5 into 10 raised to minus 6. Cancelling the terms, we get pressure is equal to 100 into 10 raised to 6 Newton per meter square. This is the amount of pressure exerted by the pen on the wooden plank. So first we will note down the given data, which is length is equal to 50 centimeters, breadth is equal to 20 centimeters, and height is 10 centimeters. The very first thing that we have to do is find the area of surface A, B, C, G. So the area of surface A, B, C, G, because it is a rectangle, it will be length into breadth. Substituting the values will be 50 into 20. We get 1000 centimeters. Now converting this into meters, we will get 0.1 meters. Now we will substitute this in the formula of pressure, where pressure is equal to force upon area. Force here is 9.8 into 10 Newton upon 0.1. You will get 98 upon 0.1, which is 980 Newton per meter square. So the pressure exerted by the surface A, B, C, D. So the pressure exerted by the surface A, B, C, D of the block on the surface of the table is 980 Newton per meter square. Now similarly we will find the pressure exerted by the surface CFBG. This is the surface CFGB on the tabletop. For finding that, we will first find the area of the surface CFBG. Area of CFGB, length into breadth. Length there is 20 centimeter and breadth is 10 centimeter. We get 200 centimeter square. Now converting it into meter, we get 0.02 meter square. Now applying this into the formula of pressure. Pressure is equal to force upon area, where force we have already derived as 98 Newton and area is 0.02 meter square. Calculating this, we will obtain 2 4s to 9, 49 into 10 raised to 2 Newton per meter square. This is the pressure exerted by the area CFBG. So applying this value in the formula of pressure, we can write pressure is equal to force upon area. As we have already derived the value of force, which is 98 Newton, divided by the area, which is 0.02 meter square, we obtain 49 into 10 raised to 2 Newton per meter square. So the force exerted by the surface CFBG on the surface of the table is 49 into 10 raised to 2 Newton per meter square. Now similarly we will find the third surface area. The third surface area we can find as the area of BEFC, which is BEFC. Now the area of that part is length into breadth. Length is 50 centimeter and breadth is 10. We get 500 centimeter square, which can be converted as 5 into 10 raised to minus 3 meter square. Now substituting this value in the formula of pressure, the pressure is equal to force upon area. Force is 98 Newton and area is 5 into 10 raised to minus 3 meter square. Dividing the terms, we get 5459.6. That is 196 into 10 raised to 10 raised to 2 Newton per meter square. The final value comes to 960 Newton per meter square. So this is the amount of force required for the block to stay on the surface of the table on the surface area DEFC. So from the previous question, we proved that maximum or the larger the area, surface area, minimum will be the pressure exerted by that surface on the other surface. Now in the next question, the given data is density of water is 10 raised to 3 kg per meter cube, while the density of copper is 8.9 into 10 raised to 3 kg per meter cube. We have to find the relative density. So as discussed previously, to find the relative density, we have to compare the density of the given substance with the density of water. So relative density is equal to density of the substance, which is copper, divided by density of water. So density of copper given is 8.9 into 10 raised to 3 kg per meter cube, and density of water is 10 raised to 3 kg per meter cube. Now cancelling the terms, we get 8.9 kg per meter cube also gets cancelled. So the relative density obtained in case of copper is 8.9. So which is our answer.